So the remaining part of the graph that we want to analyze in this particular lesson is to be able to identify any trends that show the graph is increasing, decreasing, or if it's a constant function over part of the graph. And so, as usual, we have mathematical methods of determining this, and you can see right here in the beginning bullet points, we give you a mathematical version of when a graph would be increasing over an interval based off of the comparison of the outputs f of a and f of b based off of points, the inputs of a and b. So you can read through that. Now the main point that you want to make here is that any increasing or decreasing or constant value is going to be taking place over a set interval, and we need to be able to write that interval and identify that interval. So a lot of times this is much easier to determine by visually looking at it. Now keep in mind that when we identify the interval is going to be across the domain values, and we're going to read that from left to right along the x-axis. And so if we go down here and we look at this visual, we can see pretty clearly that it's moving up and down, and then it starts to move horizontal. And we use some green points here to represent what we call critical points, and this is where the graph changes its trend. It goes from increasing to decreasing or to constant, and at that critical point it's considered constant. It's not technically increasing or decreasing at that individual point itself. So we need to keep that in mind as we write our interval notation whenever we identify that. Now, all intervals are based over the x axis, and we're reading this from left to right. And so don't get caught up with the arrows. Like this arrow looks like it's pointing down, so it seems like it would be decreasing, but technically from here to here we are actually in an increasing spot, because from, say, if I just make up this point, from this point here to go up to the critical point, we have to be increasing to that critical point. And so that interval right there, if we were to provide it some numbers, would be an increasing trend. So let's see, that's -1, -2, -3. So I have -3. And then, of course, going back this way, this goes all the way to, if you will, -infinity. And so our interval for this is going to be -infinity, -3. Now the bracketing for this is extremely important. An open parentheses means not including the value, and so we can never include an infinity value. But here, the green point is at -3, but we told you that at that point it's constant, it's no longer increasing. So we would use an open bracket to not include the -3 as well. Okay, so as we move forward here, we can see at 1, we go from -3 all the way down to the critical point at 1. So in this particular range of values, we're decreasing. And so from an interval standpoint, that would be from -3 to a +1. And again, those critical points are not included. They are open parentheses. Now don't mistake this for an ordered pair. It is just representing an interval notation. The graph from this point curves back up, and so we go back into an increasing nature. So that's 1, 2, 3, 4. So at 4, we go back to increasing, and so that would be from 1 to a +4. It's increasing. And then lastly, we get this situation where out to infinity, we have a horizontal line. So this is considered a constant. And so this is a little different. So from 4 to a +infinity, we're going to have a constant value. Now, the infinity value never gets a closed bracket because of the fact that it's infinity and it can't be equal to infinity. But in this case, we told you the critical points are part of the constant value. And so in this particular situation, the 4 is a constant value at that point, and then it's constant all the way to infinity. So we use a bracket here to include the 4. And so that's something a little different about the constant value as opposed to increasing and decreasing to the critical points. So let's go on down and see if you can see how to do this on a problem. Now, as you could tell, the visual is probably a lot easier for you to understand than the mathematical at this point, and that's perfectly fine. That's really where I want you at this point, is just to be able to identify these intervals over a visual sense. And so what I want you to do here when working sample problem number 3 is just to get a visual of the graph. And so I've gone ahead and graphed this for you, and you can see that we have a quadratic, we have an upside down parabola, and that's implying going to infinity on both sides. So it has an increasing part and it has a decreasing part. So why don't you go ahead and take a little time to graph, determine the intervals of where it's increasing and decreasing for part A. Okay, if we just briefly look at the calculator, I used a little function on there that we'll talk about later to identify this point at the very top, and its point is 5, 3. So the x value is 5. That's our critical point. That's where it changes from increasing to decreasing, and so that's what we're going to use for our interval. So once we recognize that critical point at 5, so the critical point here, x equals to 5, so we can say that this is increasing on an interval of negative infinity to 5, and of course we don't include those values, and it's decreasing from 5 to a positive infinity. And so that would be the two intervals at which this value is increasing and decreasing. So if you would go ahead and do part B, you can use your graphing calculator to help you in a similar way, since this is a little bit easier visually. And so I'm going to go ahead and write out the answer, and when you finish doing this, go back and check yourself. Okay, so hopefully your answer looks something like what I have here. Critical point at negative 3, decreasing interval from negative infinity to negative 3, and an increasing interval from negative 3 to positive infinity. Alright, so that's a quick lesson on increasing, decreasing, and constant functions.